Imagine a Viking ship on the North Atlantic. No lighthouse, no GPS, no compass needle settling toward north. Only cold water, low cloud, and a horizon that keeps disappearing. The sun is somewhere above the sky, but the sky itself is gray. There is no golden disk to follow, no clean shadow on the deck, no easy way to say that direction is west. And yet Norse sailors crossed open water. They reached Iceland, they reached Greenland, they reached the edge of North America. They moved across seas that could kill them with one wrong decision. So the question is not whether they were skilled, they clearly were. The question is how they kept their direction when the sky turned against them. One answer has become almost mythical. A crystal, a stone held to the sky, a hidden pattern of light invisible to the naked eye. The Viking sunstone. Some say it helped Norse navigators locate the sun even when clouds or fog concealed it. Some say it is the missing technology behind their ocean crossings, and some say the story has outrun the evidence. The truth is more interesting than either extreme, because the sunstone is not just a question about Vikings, it is a question about what counts as proof when physics says possible, but history says be careful. Before we talk about crystals, we need to understand the problem they were supposed to solve. Open sea navigation is not romantic when you're actually doing it. It is uncertainty multiplied by distance. On land, you can follow rivers, mountains, roads, stars over familiar valleys, and landmarks that stay still. At sea, the world moves, the ship moves, the waves move, clouds cover the sky, fog erases the horizon, wind pushes you away from your intended line. Currents carry you invisibly, and if you're wrong for long enough, you do not simply arrive late. You miss an island, you run out of supplies, you disappear. The Norse were not guessing blindly. They used the sun when they could. They used stars. They watched birds, whales, sea color, wind patterns, wave direction, currents, and the behavior of clouds near land. They knew sailing directions preserved in memory and tradition. They had skill, experience, and deep environmental reading. But the North Atlantic creates a specific problem. The sky is not always generous. If the sun is hidden near sunrise or sunset, or if clouds flatten the light, direction becomes harder to hold. That is where the sunstone theory enters. It suggests that Norse navigators may have used certain crystals to read polarized light in the sky and infer where the hidden sun was. Not magic, not a compass, not an alien device, a possible optical tool, and that is why the idea has lasted. It is strange, but it is not absurd. Light moves in waves. Most sunlight arriving around us is mixed, vibrating in many directions, but when sunlight scatters through the atmosphere, some of it becomes polarized. That means the light waves become oriented in a more organized way. You do not normally see this pattern with your eyes. The sky just looks bright blue, gray, hazy, or cloudy, but the pattern is there. Some animals can detect polarized light naturally. Certain insects use it to orient themselves. Some marine animals can sense it underwater. Humans are not good at seeing it directly, but certain materials can reveal it. That is the core of the sunstone idea. If you hold the right kind of crystal up to the sky and rotate it, the light passing through can change in brightness or split in a way that gives information about polarization. From that pattern, a trained person might estimate the position of the sun even when the sun itself is behind cloud, mist, or just below the visible horizon. The key word is estimate. This is not a glowing arrow pointing north. It is not a perfect instrument. It requires the right material, the right conditions, the right method, and a person trained to interpret what they are seeing. But in navigation, a rough estimate can still matter. If you're crossing hundreds of kilometers of ocean, small directional corrections can be the difference between finding land and passing it in the fog. That is what makes the theory so compelling. It combines a real physical phenomenon with a real navigational need. When people say Viking sunstone, they are usually talking about crystals that interact with polarized light. The most famous candidate is Iceland's spar, a clear form of calcite. Calcite can split a single image into two images because of a property called birefringence. If you place it over a line, you can see the line doubled. Rotate the crystal, and the brightness of those images can change depending on the polarization of the light. That makes calcite useful for demonstrating hidden optical structure. Other candidates have also been discussed, including cordierite and tourmaline. Different minerals behave differently. Some may work better under certain sky conditions. Some may be easier or harder to use in practice. Some may be more available in regions connected to Norse travel. This is where the story becomes more grounded. We are not imagining a mythical gem with supernatural powers. We are talking about minerals whose optical behavior can be tested in laboratories and outdoor experiments. Researchers have studied whether these stones could help locate the hidden sun under cloudy or twilight conditions. Some experiments suggest that, under certain conditions, the method can work well enough to be useful, but usefulness in a test is not the same as proof of historical use. That sentence matters, because the sunstone theory has 1 foot in physics and 1 foot in history. The physics can be tested, the history must be proven, and those are different kinds of evidence. Part of the reason the sunstone idea survives is that medieval texts mention something that sounds like a sunstone in some Norse saga material. There are references to a stone used to locate the sun under difficult conditions. That is not nothing. It is an important clue, but saga evidence is tricky. The sagas were written down after the main Viking Age. They mix memory, history, literary structure, politics, legend, and cultural identity. They can preserve real practices. They can also reshape them, so a saga reference can open a door, but it cannot carry the entire argument alone. If a text says a stone helped locate the sun, we still have to ask what kind of stone it was. Was it a real navigational instrument? Was it a literary motif? Was it a later memory of an older practice? Was it used at sea, on land, or in a courtly demonstration? Was it common, rare, symbolic, or practical? The text gives us a possibility. It does not give us a complete toolkit. That is why responsible historians tend to speak cautiously. They may say the sunstone method is plausible. They may say it is experimentally supported under some conditions. They may say it could have been used, but that is different from saying every Viking ship carried one. That stronger claim is not supported. If Vikings commonly used sunstones for navigation, we might hope to find them archaeologically a crystal in a ship burial, a navigational kit, wear patterns, storage containers, written descriptions, illustrations, repeated finds in maritime contexts. But the archaeological record is not that clean. There is no simple line of recovered Viking sunstones from ship contexts proving widespread use. That absence does not destroy the idea. Small crystals can be lost, useful objects can be repurposed as organic storage materials disappear. Many everyday tools leave weak traces, and sailors do not always bury their equipment in ways that preserve a perfect museum set for future scholars, but the absence does limit what we can claim. The responsible version of the argument is not Vikings definitely navigated with sunstones. It is certain crystals could in principle help detect the hidden sun through polarized light, and medieval references may preserve a memory of something like this. However, the scale and regularity of Viking use remain uncertain. That is less viral, but it is more honest, and honestly, it is still fascinating because we do not need to exaggerate the sunstone to make it impressive. A tool that may have helped sailors read the sky through invisible light is already remarkable. There is a mistake people make with ancient technology. They imagine the object as if it works by itself. A compass points, a phone maps, a GPS tells you where to turn. So when we hear sunstone, we imagine a magical Viking device that gives the answer. But if sunstones were used, they were not replacing skill, they were extending skill. The navigator still needed experience. They had to know the route. They had to understand the season. They had to read wind and swell. They had to judge speed, drift, and distance. They had to combine many uncertain signs into one decision. The stone would be one clue among many, not the whole system. This makes the story more human. It shifts the focus from a mysterious object to a trained mind. The most impressive part of Norse navigation was not a crystal hidden in a pouch. It was the ability to interpret a moving world. The sunstone, if used, would be part of that interpretation, an aid, a check, a way to recover the sun's direction when the sky was unclear, not a shortcut around knowledge. That distinction matters because it respects the sailors. It does not turn them into accidental owners of a magic rock. It treats them as experts in a harsh environment. Modern experiments have tried to test the sunstone idea in practical ways. Researchers have examined how different crystals behave under different sky conditions. They have tested whether users can estimate the sun's position by observing changes in brightness, image splitting, or polarization effects. Some studies suggest the method can produce useful results, especially when the sun is obscured but the sky still carries a readable polarization pattern. Other work has focused on error. How accurate is the method? How much training does it require? What happens under heavy cloud? What happens near the horizon? What happens if the navigator chooses the wrong part of the sky? What happens if the crystal is imperfect? This is where the story becomes beautifully practical. It is not enough for the method to work once. At sea, it needs to work reliably enough to help. An error of a few degrees might be manageable. A larger error repeated over days could become dangerous. So the sunstone theory is not a simple yes or no. It is a range of conditions, sometimes useful, sometimes limited, sometimes maybe not enough. That is exactly how real tools behave. They are not miracles. They have strengths and failure modes. The more we study the sunstone, the less it looks like fantasy and the more it looks like a possible piece of practical knowledge. But possible practical knowledge is still not the same as proven historical routine. That tension is the heart of the episode. The Viking sunstone story has a different emotional flavor from many impossible artifacts. It is not claiming a lost super civilization. It is not saying Vikings had modern engines or secret electricity. It does not need aliens, cover-ups, or impossible timelines. It is subtler. It says ancient sailors may have noticed something in nature that modern people usually miss. That kind of story is attractive because it flatters the past in a healthier way. It suggests attention, not magic observation, not fantasy skill, not anachronism. The best version of the sunstone theory does not make Vikings modern. It makes us less attentive. It reminds us that the world contains signals we have stopped learning to read: cloud color, bird movement, wave direction, sky brightness, the behavior of light itself. A sailor without electronics might notice things that a modern traveler never has to notice. That is the real wonder here. Not that Vikings secretly had a GPS, that they may have used the sky as an instrument. And if the sunstone helped, it was not because it replaced the sky, it was because it revealed one more layer of it. So what can we responsibly say? We can say that Norse sailors were capable navigators who crossed large stretches of open water. We can say that certain crystals can reveal polarized light. We can say that polarized light patterns can contain information about the hidden sun's position. We can say that experiments have shown sunstone-like methods can work under some conditions. We can say that medieval references make the idea historically plausible, but we cannot honestly say every Viking ship used a sunstone. We cannot say the method was the single secret behind Viking expansion. We cannot say the archaeological record proves widespread use. And we should not treat the word sunstone as if it automatically means one specific mineral used in one standard way across the Viking world. The evidence does not support that level of certainty. This is where many popular versions of the story go wrong. They take a plausible tool and inflate it into a solved mystery, but the stronger version is more careful. The sunstone may have been one navigational aid among many. It may have been rare, it may have been experimental, it may have been used in some contexts and not others. It may also be a later literary memory that only partly reflects Viking Age practice. We do not have to choose between definitely true and completely fake. History often lives in the difficult middle. The better mystery is not whether Vikings had a magic crystal. They did not need magic. The better mystery is how human beings learned to travel through dangerous uncertainty before modern instruments made the world feel measurable. How did they build confidence from partial signs? How did they teach roots across generations? How did they decide when to continue and when to turn back? How did they read an ocean that looked empty to outsiders? The sunstone gives us one possible answer, but not the whole answer. It reminds us that navigation is not a single invention. It is a culture of attention, a chain of observations, a memory system, a body of practice, a willingness to trust patterns because your life depends on them. That is much more impressive than a simple gadget story. If a sunstone was used, it was not the hero of the voyage. The navigator was. The stone was only a way of asking the sky one more question. Where is the sun hiding? And in the North Atlantic, sometimes that question could mean survival. The Viking sunstone sits in a rare category. It is mysterious without being ridiculous. The physics is real. The navigational problem is real. The medieval references are intriguing. The experiments are meaningful, but the historical proof is incomplete. That makes it a perfect case study in disciplined curiosity. We do not have to flatten the story into certainty. We can let it remain what it is. A plausible, fascinating, partially supported idea about how skilled sailors may have used hidden patterns of light to find direction when the visible sun disappeared. That is enough. In fact, it may be better than the exaggerated version, because the exaggerated version gives us a magic object. The honest version gives us something deeper. People standing on a wooden ship surrounded by gray water, holding a crystal to a clouded sky, trying to read the invisible order inside the light, not because they were primitive, not because they were modern, because they were observant. And sometimes observation is the oldest technology of all. If you want another object where the evidence is real but the interpretation is dangerous, watch the Nebra sky disk next. The sunstone asks how people read the sky at sea. The sky disk asks how people brought the sky down into metal. Both are about ancient people looking upward and leaving us to decide how much they truly knew.